We are live, Mike. We are live. Just letting you know. Test one, test one. Test one, test one. Test one, test one. Test one, test one. We are live. Test one, test one. Testing 1, 2, 3. We are live. Testing 1, 2, 3. Testing 1, 2, 3. Do we have audio? Testing 1, 2, 3. 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 Yeah, I'm gonna have to pull audio just from the actual iPad.
Testing 1, 2, 3. Testing 1, 2, 3. Testing 1, 2, 3. Testing 1, 2, 3.
Oops. Sound at the back was turned off on that computer. That is why I could not hear. Sorry, can you give me just 2 seconds?
Yeah.
All right, I think I got it. Sound is testing 1, 2, 3. Is sound up? Testing 1, 2, 3. Testing 1, 2, 3. Is sound up?
Where do you want this on the tape?
Wherever you want.
More the handheld.
Yeah.
For me, anyway.
If I want it used, let me know, okay? Okay.
I'm going to wear a turtleneck to the next one.
How's that? No? How's that?
That's perfect.
Okay.
Or use it as a handheld.
Should I just click it onto my lip?
Yeah, you can do that. What we need the Madonna. We really need the Madonna headsets.
Okay. Any better? Any better? Good. Lovely.
All right, well, I think we'll get started.
I think we should.
Yeah.
Aye.
We're here. We like math. Let's do some math, Mr. Jacobs.
Let's do it. As always, before we start any meeting, we'll pause just for a wee prayer. Does anybody have any special intentions that you'd like to share at this time? For anything that we might be holding closer to our hearts, let's join together and say Hail Mary. In the name of the Father, and the Son, and the Holy Spirit. Amen. Hail Mary, full of grace, the Lord is with thee. Blessed art thou amongst women, and blessed is the fruit of thy womb, Jesus.
Holy Mary, Mother of God, pray for us sinners now and at the hour of our death. Amen.
Father and Son and Holy Spirit. Amen.
And we'd like to acknowledge that we here in the Durham region are on the traditional lands of the Mississaugas of Scugog Island. And so we take a moment to honor that.
Okay, hands up if you've been to all 4 math cafes. Okay, so you guys officially graduate today.
Yes.
Okay, hands up if you haven't been to all 4 math cafes. Okay, you guys got to come to summer school.
Oh.
All right. Only joking. I'm expecting some more people to come because they can kind of, we're here. So as they come in, they'll join us. So we're focused on problem solving. I can't believe how quickly a year has gone, to be honest. I can't believe we're halfway through May already. We've had a ton of fun preparing these and sharing these with you. It all started with this document which came out in September from the ministry, focusing on the fundamentals. And so we focused on different things each time. This time we're focusing on problem solving. I think our own take on this is that problem solving isn't mentioned enough in this document. So we've got some ideas that we want to share with you. I know that when I talk about problem solving, a lot of adults and a lot of kids start sweating and start getting nervous. And I think a lot of this boils down to they're not quite sure how to go about solving problems. So we're going to share with you some strategies today. But I think more than anything else, hello, come and join us. We want people to go away saying, yeah, actually problem solving, even though you get stuck, even though you might not know necessarily how to solve a problem, there's a lot of joy in problem solving. There really is. And please don't look at me funny when I say that. Okay? So we're going to share with you where you can get some of these good problems and try them at home so that they're suitable for your own sons and daughters. One of the things that we're always doing as well, we're always improving our own problem-solving skills. And we're going to share some ideas what that might look like. And hopefully you will leave saying, yeah, I can help my son or daughter with their math problems. But there's a problem with problems. And I think sometimes it's the resources that we actually have in our schools. And I think there's some good questions in textbooks. But I think sometimes the questions that are given in our textbooks do too much of the thinking for students. And a question like this, and we're not going to do this because you know what, I like math, but this is boring for me, okay? But it says, do this first and do this and do this and do this. And it like walks the kids through all the steps that are actually needed. And I can think back to when I started teaching. If I gave a kid a problem, and they were working on it, what I would do, I'd go around, I'd help you. If you don't know how to do it, look, I'll solve it for you. You don't know how to do it, I'm going to solve it for you. I'm going to solve it for you, okay? And the only person then doing any thinking is basically me. And I think that's why they get to a point where they just don't know what to do because I've never given them an opportunity to get stuck and to get unstuck. So the question is, how can we get good problems that lets them get stuck without being frustrated? Well, I reckon the way we do this is change the way we might start a question. And one of the ways that we've noticed a better way of giving a problem is simply giving something like this and just say, what do you notice and what do you wonder? And this is something which works from kindergarten all the way up to grade 12. So that's what our first question to you is, okay? Chat with the people on your table for about 30 seconds and just talk about anything that you notice or anything that you wonder. Okay? Introduce yourselves and then start chatting. Okay? You seen something already? Good, good.
Get this onto the live screen.
Is there anything that you wonder?
I wonder what the pattern is.
why they're in squares.
How are you?
I wonder why there
Good to
isn't
see you.
any odd numbers.
Right, so I've heard every person say something here. And this is really important because there's lots of different ways of seeing this. There's lots of different ways everyone can approach it. There's no right or wrong answer. And this is important because now kids will tell me something and they're now invested into this problem. I basically tricked them into liking this problem. Okay? So just share with us some of the things that you might have noticed. Who's going to volunteer first? You are. Thank you very much. Brilliant. They're all even numbers. All right? Fantastic. Okay? Two plus 6 equals 8. 6 plus 8 equals 14. And does that work all the way along? Brilliant. Okay? Anything else that you might have noticed? Doesn't matter how trivial you might think it be. They're all divisible by 2. Yeah? Brilliant. It ties in with the idea of they're all even numbers. Yeah? Okay? It's a growing pattern as well. All right? Okay? So, yeah, I mean, I never said you have to go this way, did I? There's nothing to stop you going leftwards as well.
And so then what also happened is now your thinking has changed my thinking. And that's why we talk in math class, because if it was just between you and I, and then between you and I, and between you and I, we'd be exhausted. But now I'm like, oh, I wonder if what happens as I continue this with that subtraction. I've never actually done it, but now you've piqued my curiosity. And so that's another reason why we solve problems like this, so that your thinking can change somebody else's thinking in our classrooms. And I'm just going to stare at this and then continue the pattern over here. You guys just keep working.
Okay, so now we've talked about this. I do like this idea that you take the first two numbers and you add them and it gives the next box. Okay, so 6 and 8 gives 14, 8 and 14, and so on and so on. I could then say, what's number going to be in the next box? 58? Yeah, and we could continue if we wanted to. Okay, we could continue to infinity. All right, but we're not going to do that because that would take a long time. Instead, I'm going to say use this idea that the numbers in the first two add to give the third one, the second and third add to give the fourth. Use this idea, and you've got to think of a number which goes in this second box so that you're going to end up with 23 in the last box. Okay, you have this on your sheet there. Okay, so off you go, solve the problem. I ain't gonna help you. Laura's got pencils.
Yeah. So the question is, what numbers do we need to put into the 4 question mark boxes
It's the same, yes.
in order to complete the same pattern that we saw before?
The first two numbers
And if you're
add
just
them,
joining
it gives a
us,
number in the third box. Then you take a second and third,
the
add it.
third number will be comprised of
Okay.
the sum of the first 2 numbers, and the fourth number will be comprised of the previous 2 numbers, the sums of the previous 2 numbers. And if you don't know what I'm talking about, then just click back on this video and go and watch the pattern from the previous question.
At this point, I will say, you are allowed to talk to each other. Okay, it's not a test. Share some ideas of each other.
was no, for me anyways, there was no mathematical way for me to do this. It was brute force. It was try a number, trial and error.
It is. So I tried 3, but by wondering when I would try 3, I wondered if that would get high enough towards the end in order to make that 23, and I figured out it doesn't. So I'm debating now, do I go up to 7? So 1 plus 7 is 8, 7 plus 8 is 15. 8 plus 15 is 23, but I got there too early. So now I'm thinking my trial and error my number has to be between 3 and 7. I'm wondering if it's the odd number. Because in order to get to an odd number, I have to be adding odd numbers somewhere along the way.
At this point, I'm just going to stop. I do see a lot of people like this, and that's what I like to see. I like to see just a little bit of struggle, but when we're doing problems, we've got this idea. It's the ideal thing is a Goldilocks problem. Right? Not too easy, not too hard, just right. Okay, and we'll get to a point where sometimes a prompt is needed. So this is my prompt to you. One of the most effective strategies that is often not used is actually just try a number. Okay? Just try any number. If you're lucky, it might be the right answer. It might work. I know you can all add 2 numbers to get the third number, and second, third to add the fourth. You might be lucky. Okay? If not, shrug your shoulders. Use your results to change your initial number and see where that takes you. So this is trial and improvement. Some people call it guess and check. Okay? So try that and see where that takes you. Nice. I was working with some high school teachers today. And
We ended up with the same number.
yeah, that's right. Yeah, so
That's not the
okay, so now I gave this to high school teachers today, and they struggled for a bit, and then they got that, and I said, is that the only solution? And we had a fantastic discussion as to, is it the only solution? How could you find out? And that involves algebra, grade 9 algebra, yeah? So, and we even said instead of 23, could you do like 5x plus 8? Or could you make something like 40? I don't know. I've just made that number up in my head, I don't know. Well, it will work, but it might be a fraction or a decimal or something like that.
Actually, I did try
People have talked about it, but yeah, so your plan was like my plan, right? And so, yeah, then you're like, no, what if I went more systematic? What if I went, instead of like 3, 7, I went 4 or whatever, right? But, so when we have students at home that are doing something like guess and check, we have to get them to reflect. That's the part of that problem solving part. Like, why didn't it work? Like, it's too high. So.
Oh, see, oh, I see. You can't, there are limits.
Put 100 for that next one.
So this was very close. So if I give you the tip that it's a whole number.
Oh, just 3. I thought I tried 3. Okay. 4, 7.
Like sort of guiding, like there's no wrong guess.
Forward. Yeah, so we've got 4 to 1.5, 1.5 is 9, 5 and 9 is 4. Yeah, no, that happens. There you go. There you go.
Yeah.
Okay.
4, yes. Thank you.
All right.
Was 4, yes.
Okay. So, lots of things that come from that. When I've given this to the kids, they'll just say, let's start with 1 and see what happens. So you put the 1 in, 1 and 1 makes 2, 1 and 2 makes 3, 2 and 3 make 5, 3 and 5 make 8. Way too small, okay? And at that point they might say, well, maybe 2 won't work, maybe I'll try 3, they might try 3. Or they might go the other, they might start with 10, and it's way too big. But if it's too big, go smaller. If it's too small, go bigger. But eventually, you get to 4, 1 and 4 make 5, 4 and 5 make 9, 5 and 9 make 14, 9 and 14, 23. Okay, there you go. I don't think anyone expects to get this right the first time. Now, I gave this to some high school math teachers. At this school this morning, we had a meeting about good puzzles, and the question they had is this the only solution? Now, I had a sneaking suspicion that it was, okay, but I said, I don't know, prove it. And they were able to say, instead of 4, just put a number like x. What would this one be? 1 plus x. What would this one be? And you end up with an equation in terms of x, and it turns to be, I think, 5x plus 3 equals 20. And from there, x equals 4, and it shows you that there is only one solution. So you can even then develop an algebraic approach to this, if that is what you want. Okay? So from a simple little number puzzle, you can extend this now into grade 9 algebra, if you want to. Okay? You like that? Who got the answer right straight away?
No.
Oh, no, yeah.
Okay, but who eventually got the answer? All right, so this is one of the things. Keep plugging away, and you'll get there. So that's one of the first techniques we use, is just trial and error. Okay, it's a good strategy. Right, so what's the next one? Oh! Let's see.
Oh, oh.
I don't want those groans.
Right, so we can see something like this, and can be overwhelming. So there's a few things that happen when we look at this problem. We see a lot of blanks, we see some fractions, and those sort of reactions are things that happen, and we kind of talk with our kids about that. So this is entitled Fraction Fun. Thank you, Mr. Jacobs.
You're welcome.
And here's how this works. This is called an open middle problem, and there is a website for this, and we'll share that with you. Each of these boxes is going to have a single digit. Use any of the digits, 1 to 9, once only to satisfy the statement above. Okay.
So to clarify, you are allowed to use 1 and 2 again. These are just given to you. If you want to put a 1 or 2 in any of these, you still have to.
And remember, you can talk, and you can work together, and you can suggest things.
How are you? Okay. Yeah, you got 3 people watching it. Yeah. So there's different ways of looking at this one. Sometimes people kind of think of a number less than a half. So, okay, you know what? So this is saying that these two fractions are equal to each other, but that this one is smaller than that. This one is smaller than that one. Okay? So in terms of where to start, I might think of something that I can put here and here, but I know that these fractions have to be smaller than a half. So can I just pause for 1 second? I sometimes also find it useful just to write the numbers that I can use there. And as I write them down, I'll cross them off. Okay? So my first thing might be or even maybe think, can you think of a fraction which is less than a half? Yeah. Yeah, okay, so that's good thinking there. You're thinking of 1/8. But then you need 2/16, and we can't do that. And we've already used the 1 there. But I'm wondering if you put the 1/4 there.
That's a lot of reasoning in that sense. Yeah. How about you?
Yeah, I used slightly different numbers than him.
Okay, so we know that there's more than
I started with 1/4.
Okay.
And that's 1/4 over that.
Okay.
And then I knew 1/4, if I made that 2/3, 1/3, sorry.
Okay.
3 into 6 is less than a half.
Okay. So I'm gonna.
What fractions do I know that are less than 1/2? That I can work with easily. I'm not going to think of 1/27 or 1/11.
This is a lot easier problem.
Say that again?
I thought all these, like I thought that they were all less than, but then I thought they all had to add up to equal that, but they don't. So it's a much easier problem than what I was making it out to be.
What I like about this question is that you've got a solution, and I'm going to say that.
Different answer. Oh wow.
Okay? How we get that? You didn't shoot. Oh, okay. Okay, so no, this is, okay. No, that's right. I should have maybe explained more. Exactly. No, I bet you won't. So these are equal. This is where that, this is small. Okay? Now, I'm going around and I'm seeing lots of progress. Please don't take the fact that I'm not actually giving the answer as I'm ignoring you or being antisocial. Is that sometimes you're just that close to getting the answer, and I don't want to rob you of that excitement. Okay? I don't want to step in and finish it for you because it will ruin the fun. Really? Oh, there is another answer. Yeah. And these, what's good about these is going to things that most students still other teachers say, good. You prove that you found it. And that's really, really special thinking. So if everyone can work on the same problem, which is always a good thing in terms of making progress. So teaching makes my job a little bit easier. You know? I'm just going to take the time. And each one will make a little bit more. It's a good thing.
How are we making out there? You done? Okay. Two different answers. So find a different answer. You're just going to swap papers, aren't you? So my follow-up question then would be, can you find all the possible solutions? So, yeah, I think. Yeah, definitely.
So one of the things that we have talked about in our math cafes this year is we've talked a little bit about concrete, diagrammatic, and symbolic. And so this question resides in that symbolic part, or where we see numbers and signs and things like that. So depending on our students and where we are in our learning, we might have something at the tables for them. So fraction circles or fraction strips are going to help students here to understand and be able to compare fractions with that visual. So when they're looking at that, they can see, okay, I need something less than a half. But now that I know what half is with my fraction strips, I can find something that's going to include that. We don't have fraction strips with us this evening, but what is another kind of plan? So aside from having some manipulative, what are some plans that you might have had for this particular question? Particularly, where did you start from? Did you start from the right? Did you start from the left? Did you start one spot and then change your mind part way?
Start from the left.
Okay, you started from the left and then worked your way to the right? Yeah. Okay, anybody start at the right and work their way left?
Oh, okay.
Okay?
We did.
Yeah. So sometimes a strategy is so starting with the answer or working backwards might work here. It depends. If you have a real affinity for equivalent fractions, and I think, they have their time and place, that might be a great place because you know what kind of things work with those digits and those numbers.
And I think a lot of you spotted that because these have to be less than a half. What fractions might you start with? Well, I'm looking at maybe a half and maybe a third. I don't fancy doing anything like a 17th or a 13th, especially because they're single digit numbers. So I might start with, I think, a quarter, I beg your pardon. I go there and I know that I think is the only possibility for the equivalent fractions, a quarter and 2/8. I can't do 3/12. Okay, that's my starting point. I've got those. Now I've got some numbers left. And I even see kids even doing something like this, 2 and 8, 1 and 4. Okay, now what numbers do we have left? We've got 3, 5, 6, 7, 9. How can I make something that's bigger than a quarter, but less than a half, using 3, 6, 7, 9? I guess there's lots of ways, isn't there? I can do 3/7. Yeah. I can do 3/9. That works as well, doesn't it? Okay. Can't do 3/6. Okay. So I think for the quarters, I think there's those two possible answers. So I know you'd got 2, and I think that was the third one there. Okay. From a teaching point of view, what we like about this question, if a kid gets a solution, okay, and other kids are still working on it, then it's the easiest thing for us as a teacher to say, good, find me another answer. And when they come up with another answer, say, good, find me another answer. And then you can say, can you prove that you've got all the possible solutions? And that way, it does help us keep the class together, at the same time enriching, because to ask a student to prove that you've got all the possible answers is actually some really deep thinking in terms of math there. Okay?
So you may hear your students or your child coming home and they have a question and it's an open problem where there's not like one final solution. So sometimes we push that so that kids understand a particular concept, and then other times, for example, in the question in the textbook that we were showing earlier, there's one, it's a closed question in that there is really only one answer and generally one way of getting that answer. So those are sort of two ideas in math education right now. All right, Mr. Jacobs.
Okay, so are we going to do this?
I think we are.
Okay,
So,
should we do the problem first?
why don't we talk about the problem
Yeah,
first?
let's talk about it.
Okay.
Oh, no, that's not.
Yeah.
Yeah, we won't do that one.
All right, so Mr. Jacobs is going to be my demonstrator. And something else that we haven't haven't talked about in terms of a strategy is that whole idea of making a list. Making a list is a great idea when you're trying to solve a problem. Mr. Jacob has included the numbers 1 to 10, and he has 4 operations. Is there somebody who has a favorite operation that they would really like us to do out of adding, subtracting, multiplying, and dividing? Is there a favorite operation that you really want us to do?
Don't be shy. I need a 5th operation.
I heard adding.
Adding? Okay, I'll do another adding one then.
All right, so we now have 5 operations. Adding is going to be done twice. So here is your task. You are going to...
So should we create 5 equations first?
Sure.
So somebody give me 2 numbers and 1 operation. Just choose any 2 numbers and 1 operation. 4 and 5 and times, okay? So I'm going to cross off the 4 and the 5, and I'm going to cross off that. 4 times 5 equals 20. Give me another 2 operations. Oh, another 2 numbers and 1 operation.
10 divided by 2.
Okay, thank you for saying that. That makes it easier for us. 10 divided by 2 equals 5. Brilliant, okay? Another 2 and an operation.
3 minus 1.
3 minus 1, so 3 minus 1. Do that one in my head.
8 plus 9.
Which one?
8 plus 9.
Plus 9.
8 plus 9. 8 plus, that's the 8, that's the other plus there, the 9. And that's the one that we chose. Okay, so that's like a wild card. Okay, 8 plus 9 is 17. And then what have we got left?
6, 7.
6 plus 7.
6. I guess 6 plus 7 equals 13. All right? Are you happy with that? Because you're not going to do that. What's going to happen is this. We're just going to give you the answers. You've got to decide where the numbers go, and you've got to decide what the 5th operation is. You can choose that 5th operation yourself. Okay? We're giving you the answers. You're going to come up with the questions. You can only use the numbers 1 to 10 once. The 4 operations plus 1 of your own choosing. Okay? How are we going to do this?
Yes, and how are we going to do this? So there's been some research done by, he's a Canadian researcher, Peter Lillardale, and his research is around what's called a thinking classroom. And the idea being that we want our students to be thinking as long and as quickly as possible when we do things like math, science, history, any of these kinds of things. So we're actually going to show you a bit of a structure that's happening in some of our both elementary and secondary classrooms, and it's called the thinking classroom. You are getting a card, and you are going to be put in what are called visibly random groups. So that means that you could be working with any number of people in this room. There's going to either be 2 or 3 of you. And the reason we do that is so that kids get to the thinking right away. Because if they choose the groups, they tend to choose their friends. So you're going to have, we've visibly randomly grouped you. That's one of the key pieces. The other thing that is we're going to ask you to do, you're going to be working at a vertical, non-permanent surface. So you see that we have some whiteboards that are around the room. So kids getting up, standing at a vertical surface, and it being non-permanent in nature, there's research to prove that kids get to the thinking quicker. So, you're right, it's a change in position. There's that non-threatening part because you can just erase it. We're all kind of in this together. where I'm not necessarily with my friends, and you're going to kind of try and get to the question. You're going to get there, and you're going to be like, what was the question? Again, you are looking to make sense of it, and that's what our kids are doing. So we aren't giving you a lot of written instructions, we're giving you this. So that right away when you get to those boards, you think, okay, yeah, what is it that we gotta do? Come on, we're gonna try these things out and get to the work right away. So, Mr. Jacobs, what cards have you passed out?
So I've given you all cards, okay? Look at your card. That's what group you're going to be in. At the back, we've got the 5 boards. I've labelled them 1, or ace, 2, 3, 4, 5. There's 1 marker at each of those boards. So you're going to be in groups of 3, working together, tackling this problem. Introduce yourself when you get there. You are allowed to talk. In fact, we encourage it. And your problem is this. You've got to come up with those 5 solutions. 17, 2, 21, 3, and 2. Okay? Use those 10 numbers once only, the 4 operations once only, plus 1 of your own choosing. Okay? Up again. Go to the boards. Thank you very much. Thank you. Number 1's over there.
Yet.
I'm not a math genius.
Yet. Not a math genius
Don't rely on
yet.
me.
Do you guys mind if we tape this for the live stream?
Sure.
Awesome.
So, should we start working?
Yeah, definitely. So we need.
So 1, 2, 3, 4, 5, 6, 8, 9, and all the operations. I put mine on the...
And 10 as well.
Oh yeah, I left mine on the table. And then, do we just pick randomly?
Well, so we need the numbers. So the answers are 17.
Oh yeah, hold on.
Oh, you wrote them down already?
17, 2, 21, 3, 2.
Oh, yeah, 3 and 2.
So, do you want to start?
Yeah,
Just
just
like
start throwing numbers to it. Sure. Let's see.
10 plus 7.
Say 8 divided by 4.
Divided by 4.
1.
7 times 3. Oh, we already used it.
Is there any other way to get to 21?
I don't
I'm not
know.
sure there is. I think it's 7 times 3 is 1. So let's get rid of that one and go
7
7
times 3. 7 times 3.
What can we get to 17 now again?
So, what did I pick out there? 10
10 plus 7,
7?
yeah.
Okay.
So we can go 9 plus 8 over on the 17.
9 plus 8.
And then maybe change the 8 divided by 4 to 4 divided by 2.
9 plus 8, 4 divided by 2. Okay, so we got that.
Okay, and then 3
Okay,
and
3
2.
is 5 minus 2?
Yeah,
For
5
3,
minus
5 no, we already, I have 2 already.
Okay.
Sorry. How can I get 2 thirds? No, we already used 10. Or can we,
Well, we need to
Oh, we
we need to
still
use
need
at
to
least
use
one more.
another
Yeah.
number here.
Well, what do we need to use still? Subtraction, right?
yeah.
I think we need the 3 here, right? I think that's the
Yeah.
one that gets the 20.
So maybe let's, this is a difficult one, so maybe, let's do
Do 4 divided by 2, you think?
yeah, for now. So let's do
5 minus 2.
for this, right? 5 minus 2.
So now we need a division to 2.
So what was we have like 6?
No. Well, there's 2 2s.
Where?
Yeah, these 2 are both 2s. Okay.
Hold on. Yeah.
Right?
It's right, right? Is that right?
Yeah,
17,
yeah,
2, 21,
yeah,
3?
yeah.
No, 17, 2, 21, 3.
3 and 2.
2.
Yeah.
Oh, okay, there's 2.
So what do we have left here? 6,
Okay, so
1.
we have 10. So should we start?
Hold on, what do we have left here? 1,
We have 10, 6, 1.
so 6 minus
Right.
4. 6, oh no, we already have it. Oh, we can use it again.
So 6 minus 4, so
And then what else do we have left?
we have plus, minus, times, right? So we don't have division yet. 6 nothing.
2, 3, 4, 5, 6, 7, 8, 9. 2, so we got 10, 1.
Should we
Let's
start
say
over?
maybe. Well, there's some that we think we need to keep. I think 7 times 3.
Yeah, this we can
so we can
keep.
keep that one.
Right?
What else gets to 17? 10.
10.
We can't use 10
No,
and 7.
we have 7.
9 and 8. And that's the only one. That has to be 9 plus 8. Right?
9 plus 8. Okay, so
So those have to be used, right? All right.
okay.
So now we have
So,
division.
so we have plus. So we still use that. So,
Oh, the 9, you know.
oh, we already have 8. 10 divided by 5, no.
Well, we can go. So what's left? 6.
1, 2, 4, 5, 6, 10.
1, 2, 4, 5, 6, 10. 1, 2, 4,
Yeah.
5, 6, 10. The only way to do so to
We have these 2.
so we need to use division and we need to use subtraction. 1, 2, 4, 5, 6.
So 6 minus 2 is 4. 6 minus 4 is 2.
Okay. So 1, 2, 1, 2, 5, and 10, right?
Yeah.
So 5 minus
10 divided by
10
5.
divided by, we have 10 divided by 5. Left here.
Minus 10 divided by 5. So we have 2, 1. 2
2
plus
plus
1?
1.
Yeah.
Yay!
Celebration!
Yay!
Sweet.
That's good. I didn't think we would get it, but that's fine.
Nice.
Nice.
What did you start? I don't know. This is like our second try already. Because we erased.
Oh, did you get it?
I think we ended up thinking we have to have that.
Just this, because this is.
Then
So then we realized, okay, we gotta go to, yeah, we did a couple of the 2s, and then we
Yeah.
realized, oh, wait, 9's the one you should start with.
Yeah. It's funny how you don't think about it to begin with. It just comes to you.
Yeah. If the person spent a couple minutes thinking about
That's my excuse.
elimination, you'll save trial.
Yeah. I find myself sometimes, it's only when I try some things that it all becomes clear. Go, oh, hang on, we can't do that.
That's what happened. That's exactly what happened. We went through a couple of 2s, and then we went, wait a minute, 9's effective.
Exactly. Yeah. And it goes back to the whole thing. Just try something, and it'll make it clear. Good. Well, where's Christine? Is there another one? Oh, you put it. Do you want to?
Well, I didn't know where we were.
Or do you want to do the?
We should do the question.
Can we just stop you for a minute there? We've got 5 sets of these, and we can spend all evening doing all of them, right? Did you enjoy that?
Yeah, I know.
It made you think, but there's some good thinking going on. What numbers do you start with? I think a lot of you started with a 21 and the 17 to begin with. And for the second set, it's only after you try a few you go, oh, hang on, the 9 is the important one. And sometimes that's what happens with problem solving, is that you only figure out what to do just by getting stuck in to the actual problem, saying, oh, now I know what to do. Really good work. You see what a difference standing up makes and talking to people, okay? It's sometimes a lot better than sitting down like this, because you can bounce lots of really good ideas off each other. From a teaching point of view, it's fantastic for us,
Because we can stand here and we can see exactly where everyone is. And we can say, right, you guys are fine. You guys aren't paying attention. These guys aren't paying attention to me at all. It's because the math is fun, yeah. But it really is powerful for teaching us. Now, it's not that every single lesson is going to be like this, but we really understand now that this is a great way to get kids more comfortable with solving problems by learning off each other and being okay to make mistakes. That's why it's an erasable surface and not like a permanent surface. Because all of us made a mistake at this point, and what do? Just erase it and start it again. Okay? So you're more likely to take risks. Should we give them the next one?
I think we should. Now, because we like to do things also spatially, you have a set of what are called pentominoes. Can you take those out? And if you don't have a flat surface that's kind of near you, you probably are going to need one. So this is a task that's called Precious Pentominoes. And you can see at the front that there are two illustrations. And what we would like to do, Mr. Jacobs is going to take you through this task. He's going to explain the...
So you're going to choose two pentominoes to make a precious ornament. Okay? You're going to put two pentominoes together. But there's an important criteria. Firstly, when you put the two together, it must be symmetrical. Okay? So do you see the one on the left? That's not symmetrical. That's not. Also, it must be a closed shape. You can't have any gaps. So the one on the right is symmetrical, but you see there's a gap in the middle.
No closed, or it must be closed.
So it's got to be symmetrical, it's got to be closed. Okay? When you come up with something, and it might be like this example here, so you see, symmetrical, it's closed, you're going to find three things. Firstly, you're going to find the perimeter. That's the sum of all the sides. In this case, perimeter is 18. Check each other. People have been known to miscount. Secondly, you're going to find the area. How many squares are covered? In this case, it's 10. Finally, you're going to find the number of sides of your shape. In this case, I believe there are 12 sides. Okay? You've got three numbers. Perimeter, area, number of sides.
Perimeter,
now you can work
area,
out how precious your pentomino is. You're going to use a formula for this. Okay? To get the cost of your precious pentomino, you do perimeter plus area. Got to do that first. Don't break any math rules. And then you multiply by the number of sides. So my perimeter is 18, my area is 10. 18 plus 10 is 28. Multiply that by the number of sides, 12, gives me $336. Okay, your task is to find the most expensive and precious pentomino.
Find the most expensive.
We will give you 10 minutes to make progress with this. Okay? Yes, anything work, yeah. Still as a group. Still as a group, yeah. Use 2. You only use 2 to make it, yeah. Got to be symmetrical. Only use 2, yeah. So good. So that's the first one. So now let's work out what's that one. And if you want, you can show your working out on your board. Okay. So I've seen you've done one already. Brilliant. Okay. Symmetrical, close, and tapping. So let's work out the cost of this. So we're going to work out the perimeter first. So I'm going to remember that starting this point. 3, 11, 14. Right, so let's make a note of that. So perimeter is 14. What's the area?
If you don't have pentominoes at home, we have put a link to a website in the chat that you can go to take a look at the 12 different pentominoes that you can create using 5 squares. So in the chat, there is a URL to a site that will show you all of the different pentominoes that you can use to make your precious pentomino.
We've got our 3 numbers. We've got our 3 numbers. So now we're going to work on the cost. Perimeter plus area. 14 plus 10. Times by 8. 192. That costs $192. Okay? Find something which is more expensive. 2 pieces, yeah. But you can use these again. Okay? Alright, try it. See what happens. Okay.
Again, for those of you working at home, if you want to see a list of all the pentominoes that you can use, you can go to the website in the chat. It's http://COOLMAGNETMAN.com/pent, PENT.htm. For a list of pentominoes. Again, the task is take any 2 pentominoes, put them together to create a symmetrical shape with no gaps in the shape. And then you are to find the cost of your precious pentomino. The cost is equal to the perimeter plus the area, and then multiply that by the number of sides. And the goal is to get the highest cost possible, or to maximize the cost of your pentomino using the formula perimeter plus area times the number of sides. Again, you can take a look at all the precious pentominoes. You're supposed to put 2 of them together, and you can find those precious pentominoes at http://coolmagnetman.com/pent.htm. That website URL is also listed in the chat alongside this video.
because it's multiplication. So now it's a question of what sort of arrangements can you do to increase the number of sides, and I saw some fantastic discussions going on. That's got lots of perimeter, which is great, but in terms of the number of sides, oh, we've wasted all those edges there. That's just one. What a waste. What a waste that is. And I'm quoting somebody there, okay? So, but great realizing. How many of you realize that each time the area was always going to be 10? Yeah, okay. Now, we purposely didn't tell you, but it's funny that when you do this with kids, they're going, oh my gosh, the area is 10 again. What are the chances of that happening? And then somebody kind of goes,
Oh, they're 10.
5, hence, ominous, oh, it's always going to be 10. But yeah, you know what? You've done the thinking about yourself. I ain't going to do the thinking for you, okay? So, what was the highest price? What was the most expensive one that we got?
640.
640? 640? 640? 640. Okay? And I believe it was something like that, was it? Something along those lines? Yeah?
Ours was the T.
You had the cross.
Yeah, it's a cross and a T.
Like that?
Yep.
Okay. Yeah. Very interesting.
Hopscotch.
What did you say?
Somebody said hopscotch.
Hopscotch, right?
Hopscotch, yeah, there we go.
Yeah.
Okay. All right. Did you enjoy it?
We did.
Okay. So why are we doing this one? Well, it's great. Kids learn a lot about symmetry for this, but it's also, from our point of view as a teacher, it helps us figure out who really understands perimeter and who's having trouble with perimeter. Okay. Who's counting the actual length of the sides carefully and who isn't. So it's a great one to learn about perimeter. It's also a great one for simple substitution into formulas. Okay. So, we're going to go back to our chairs. Now, you can leave all that here. We'll
Yes, yeah, sure. I'll put them up there for you. Okay. Do you want to just take a wee photo?
I've had a request. If you want to do all 5 sets for that 10 questions task, there you go. Something to do over the long weekend.
Okay.
So something that I noticed is that there was a sense of a little bit for this evening, a sense of community, right? You were like high-fiving when you got the answer with somebody that you might not have known unless you've been to all 4, somebody that you sort of recognize. And so you can imagine what happens over the course of a semester in high school when those groups are changed, when those groups, that's kind of just the norm. You kind of get to know people that you might not have known. You get to learn from people that you might not have learned from. So we also are noticing that as well. So when we look at our curriculum, we do have the expectations that are often talked about in our report cards and things like that, but also within our Ontario curriculum, there are what are called math processes. And the processes stay the same no matter what grade that you're in. So they talk about them in kindergarten all the way into secondary. And the math processes involve problem solving, reasoning and proving, reflecting, selecting tools and computational strategies, connecting, representing, and communicating. And even if you just thought about your own personal experience here tonight, about some of those things, you've probably done at least 5, if not 6 or 7 of those things.
Probably done all of them, to be honest.
Right, like you were reflecting, you were checking on your answers, you were making connections between things that you hadn't seen before, but you knew of. So there's lots of those things. And we believe that this is really what is at the root of math curriculum. So it's beyond getting back to the basic facts and things like that. These are job skills, right? These are the things that we want our kids to know. So this is how we learn our math and how we practice our facts, is by doing some of these things.
Yeah, and all of these are kind of action words, aren't they? Representing, communicating, the things that you're actually doing. And for me, math is a doing sort of thing. And yeah, and you covered the idea that sometimes kids will say, when am I ever going to have to do this? Okay, so working with factoring trinomials. Now, I like factoring trinomials, you know, I just find it therapeutic, okay? But I will, you know, admit that maybe you might never have to factor a trinomial in your life ever again, okay? But I can come up with some good problems which involves factoring trinomials, which involves all of these. So sometimes when a kid says, well, when will I ever have to do this? I say, you might not. But you know what you will need to do? You'll need how to problem solve when you're in a job. You'll need how to reason and prove when you're in a job. You'll need to reflect on what you're doing in a job. You'll need to select the right tools and strategies. You'll need to do all of these in a job. So these are skills, these are actions which you're going to develop through math, and that's going to make you better when you're actually out there in the workplace. Okay? What does EQAO say about it? There's lots of talk about EQAO scores and things like that. So the people who are setting these tests, they say something which is a little bit different to what the government might say. And this is a direct quote from something they just released just last month. The challenge with mathematics in Ontario may be less about students knowing math and more about their ability to apply math knowledge and to engage in related critical thinking. And we've talked about this before, previous ones. You know, we said, do kids need to know their facts? Yeah, they do. It's really important, and also it's fun, okay? But once you know your facts, okay, it's really important to give good problem-solving activities, like the one we did with the 10 numbers, where you can use all the problem-solving processes to actually to solve certain situations. Knowledge and understanding scores are always very good. Our critical thinking scores, they're lower. We kind of expect that, but if we're going to improve math scores, it's not so much focusing on these, but focusing on how can we get our kids to be better problem solvers. To become better problem solvers, you've got to solve problems. That's how you develop your problem solving skills. That's a boring slide, I'll leave that one. Okay, so should we try some EQO problems? So on the second side, or the second page, should we do one of each? What do you think?
Let's start with this one.
This one?
Yeah.
Okay. So these are primary problem solving questions. There are some questions from EQO that I really like. I think they're very fair questions. There are others that, I'll be fair, I think worded better or put better. Okay. So here's a couple of primary questions. I think you might have seen the money one before, but just have a little go at those. And as you do them, think about, when you're a grade 3 student, what might you find easy about this question? What might you find difficult? Okay, because our grade 3 students have to do these questions. Okay, and again, you're allowed to talk. It's not really EQAO. Okay, so you're not going to be disqualified if you talk to each other. Yeah, it's there's a keyword. Okay, so we go set the view, and then model it with our model. I say this is one of the things we can do, use our models to help us. And then do okay. if you've done those first two primary ones, make a start with the junior ones. How are you getting on? Do you know how many kids said that? It's you start, of course, they start with a higher number. Yeah, it's just one of those things. Yeah. You also know that some people fill this one in first, and then fill that one in, and because they fill this one in first, they say that we all got there first. Which one are you working on? Yeah, there's.
So let's say 695. Divided by 10 would be 6
Aye, I would 138, 1 plus 139. Yeah. See, if you play a lot of darts and you see 480 and you see 3, you just see 16s. Treble 16 is 48. So you just see that's a sign of a misspent childhood on my part. What do you think? What do you think of this question?
It is a trick one with the class.
So I had to read that 3 times before I figured exactly what I needed to do. Yeah.
And I think that's probably, I know my kids say that's the things, especially when I'm really good at that. Kind of get them to slow down, read the question.
It's
How do you do that?
it's
Drill it into them?
no. I'll be honest. Is that I've even known math teachers who you just get lulled into a false sense of security, and you just don't see that. You just it is a habit of mind where you say, take your time, take your time. Exactly. Yeah. And it's not that you don't understand what's going on. It's on another day, you might have picked up on that word, okay? But on this particular day, on this exam, unlucky. You get 0 for that question. Yeah. So this is one of the things.
But in terms of, can you just help people get them to keep slowing down?
Yeah. So it's one of the things is that is read it once, read it twice, read it 3 times. But then again, if you read it 3 times quickly, you could, it's a hard thing to do. I myself, I think that when I give a question to a kid, it should be clear. I don't want to do any gotcha questions, and I'm concerned that sometimes that this is a gotcha question, like, this is the way did it need to be this complicated? I mean, listen, each student needs 2,406 popsicle sticks. That's not a real world problem. Do you know what that looks like? 2,406 popsicle sticks, So.
All right, ladies and gentlemen, I see lots of us have gone and we're sort of working away at some of the other problems, which is great. We're going to take a look at these 2 primary questions. And when you look at them, is there anything that you think an 8-year-old might find challenging? Okay, the coins. Yeah. Right, so there is...
No, I still struggle. I mean, I've been in this country 19 years, and I still have to look very carefully. And the fact that your 10 cent is smaller than your 5 cent, like, what's up with that? I mean, yeah, okay. Yeah, so this is a thing. And when we are using money, I like to have actual money I think one of the problems with this question is that unless the kids have got the money in front of them, it can be quite a difficult problem to access. You know, if the coins are in front of them, then maybe they'll say, "Oh, spend $1.75," and they might move the toonie out of the way and says, "Well, that will cover it, and I'll get 25 cents back, and then I've got to do 25 cents plus the rest, and maybe that will make it a little bit easier." This is not how I would ask a question to test somebody's money sense. In this kind of symbolic way, I would give money to the kids and get them to show me, you know, can you count this amount? Can you give me change from this amount? So it's a tough question for an 8-year-old to get correct, and we often don't score provincially very highly on that sort of question.
And what about the patterning question? There were some interesting comments and discussion there between Danielle and Jeff's pattern. Whose pattern will reach 100 first?
There is a classic mistake that kids always make. Danielle starts at 76. Oh, Jeff, he starts at 55. There's no way he's going to catch up. And so that's it. Danielle starts higher, so therefore she's going to get there first. I mean, even look, like after 3, she's still in the lead. Yeah, so she's definitely going to win. So kids will justify it. Yeah, she starts higher. At the 3rd one, she's still higher. Therefore, she's going to win. And they don't follow the pattern through, unfortunately. Yeah.
Yeah, and that would be something that we work at in grade 7 and 8, where they would know the total, and then they'd have to work out to find the term number. Absolutely, yeah. Yeah, in grade 7 and 8 that they would do that.
So something like this is getting kids to be familiar with these sorts of questions, is that you can't just, it's not, a question like this isn't going to be that quick. You can't say, oh, they start higher, so it's going to be first to finish. They won't give you that big space to do it. So continue the pattern. You know, show your work, show you're going up by 4 each time. Be prepared to be surprised by some of these ones. I think a lot of you jumped ahead to the junior questions. I'm just going to say this particular question here, question 16, with the popsicle sticks, I had to read 3 or 4 times before I was confident that I was doing the right thing. And it's very easy to read a question quickly and miss one little word, and it messes everything up. The other thing which bugs me about this question is that each child has to get 2,406 popsicle sticks. Now, bearing in mind that was what 100 popsicle sticks. I've got to get 24 packets like that, plus another. I don't think this is real life.
Every parent is like, do not send this science project home.
Yeah.
Do not.
And they're very precise. It's not 2,400, it's 2,406. I'm just picturing the situation where the teacher says, no, you've only got 2,405, go back and get another one. But it's, so those are things which, but it's, there's lots of reading going on. And if you just wake up on the wrong side of bed one day and you miss out one word, then you get this question wrong, okay? The next day, you might get up on the right side of bed and you read the question correctly and you get it right, okay? And that's how, what the fine line is on EQAO, that it's, you know, one day you get 0, the next day you get the full marks for it. This particular one here says how much cheaper is one flag at store A than store B. We know sometimes kids don't make sense of the actual context. Some kids think, well, if you just want one flag, get it at store B. Okay, because you're paying less, $4.80 compared to $5.60. But they're not making sense. We're talking about the rate per thing. I think a better question would be, if you want to buy 15 flags, which store should you go to? And that way, we're getting into multiples, or you're getting into unit rates. And I think that's a much better question. I think this is a little bit too wordy, okay? And can, like, just confuse the context or confuse the students a little bit. We're going to move on. You remember this, don't you? Concrete, diagrammatic, symbolic. And do you remember working with these blocks to learn about bar models? So we thought we'd end this session by just showing you, suppose you got a word problem, a number problem, and your kids can't figure out what operation to use. What sort of strategies can you use as parents to help them clarify their thinking? And so for us, these types of bar models are an absolutely fantastic way to help kids see what operations go on. Now, we know that, and I'm speaking for experience here, is that I sometimes got my students to try and make sense of a word problem by decoding certain words. And I would have had a chart like this up in my classroom. Said, okay, all these words mean addition. If you see these words, it's going to mean add. If you see any of these words, it's going to mean subtraction. Okay? And you see if any of these words, it mean multiplication. And any of these words, if you see them, it means you got to divide. And I put that up with all good intentions. And I kind of realize now that I was actually doing my students a disservice, because you know what? Sometimes you'll see all together and it's nothing to do with addition. It'll be something to do with division. And sometimes you will see left and it's nothing to do with subtraction. It'll actually be something to do with division. So one of the things we're doing when we work with teachers is say, maybe not rely so much on finding a key word. Think about the actual problem itself. For example, here is an EQO question. Now, if I rely on keywords, I'm looking through here, what have I got? I've got this words, I've got, oh, left. Where's left? Oh, it means subtraction. I'm thinking, right, which numbers do I subtract here? And it's actually, subtraction's not really got much to do with it here. But what I've got to do is think about what is actually going on, and I'm going to do that by actually drawing a bar model to figure out what's going on. Brock has 112 trading cards. Right. That's my start. This isn't a scale, but I know Brock has 112 trading cards. His brother gives him 108 more. So what would I do for this diagram? I'm going to add to this. Now, I don't want to draw every single trading card, because that's going to take forever, all right? And sometimes with some of the younger grades, that's what they do. They draw. No, I ain't got time for that. I'm going to draw 108 more, okay? How much does he have now? 220? Yeah, so I can just put this on here. I can just say this person now has 220. And now what does he do? He then gives away 130 cards to a friend. Okay, so I've got 220, and I'm now, and I might just say, okay, so this is what I've got at the moment. And if I want to draw a new bar to make that's my next line of working out, I'm going to do that. I now give away 130 cards to a friend. So how could I show that? Well, I might say 130 is about that much. I'm going to get rid of that much. And what do I need to find? That's what I need to find. How am I going to do that? How am I going to find that amount? Subtraction. You could do 220, take away 130. Is there something else you can do? You can add up from 130. So we got two options here. We can do 220, take away 130 to get the answer. Or we can do 130 plus something equals 220. And depending upon the actual numbers, one might be a better way to do it than the other. In this case here, just for fits and giggles, who'd want to do 220 take away 130? Who'd want to do 130 plus something equals 220 the proper way? I'm only joking, okay? You do what's right for you, okay? If it's 199 plus something equals 200, I think we're all going to count up, yeah? If it's 1 and 200, I think we're all going to take away. It all depends on the numbers. But what's happening here is that the bars, when you draw them, it actually shows you what sort of operation you need to use to actually solve that. So if you ever got a word problem like this, which you're solving with your son or daughters, if they're bringing home practice EQL questions, okay, try this approach. It's something which extends all the way into high school. But should we do, what are we going to do? How much time we got? We're here till 10 o'clock, aren't we? Is that right?
Well, there are those people that didn't come to all four.
That's right, yeah.
But you can see where that's a sense making. We talked about getting kids thinking. That's thinking, whereas the previous one was matching. I find the word, I match it to the chart, that tells me what to do, and we lose what actually happened in the problem.
Yeah, let's try this one. Now, I think a lot of you could solve this using the symbols, but put yourself in the position now where your son or daughter is saying, the symbols don't work, can you draw something to help me think about that? So we're practicing now how to help our sons and daughters. So we're going to ask you, can you draw a bar model to show what's going on here? Okay, work together. We'll give you like 2 or 3 minutes to think through this, and then I'll show you what happened in a grade 7, grade 8 class. Okay?
I was thinking sort of this way, right? It's the same thing, yeah. But for some reason I think horizontally. Okay. 600, 600. It's the same thing, yeah. So 3/4 of them leave after the first period. Right. And then how many for the third? So 1/3 of that, yeah. Then I guess you could just take that 600 and divide it into thirds, right? Yeah. So you got 200, 400, 200, 200, 200. And then how many leave? 1/3. For the third, yeah. So you're left with 400. Yeah.
Okay, so this is 600 there, 600 here, 600, and 600. Okay, and these guys, they all leave. So how many do we have left? Okay, so now I'm going to draw a new bar.
It's easier when you draw.
Good boy.
So good, yeah. The pizza.
The pizza.
You can tell we like eating. What threw me off is where's the third of the remaining things? At first I didn't read the remaining things and I was like, is it the whole thing? And so I had to go and read it again. Yeah.
Okay.
Well done. This is probably something that you didn't learn when you were at school. I certainly didn't learn to do this, and I'm in a better position now to help students because I can show this bar model. And the more you do these, the better you are at explaining to your sons and daughters. I'll show you what happened in a grade 7 8. This is the first time they'd ever tried it. Their teacher said they were really having issues with word problems to do with fractions and things like that. And I said, so I went in and basically, I started off by saying, what is 1/5 of 200? And they would tell me, oh, you just do 200 divided by 5. Okay, so 40 fifths. So what about 3/5? And I drew a bar model. If 1/5 is 200, if 1/5 is 40, what would 3/5? And they went, oh, 40, 40, and 40. Right, 120. Now try this problem. So this is the student who's working on it basically for the first time. Oh.
3/4 lead at the end of the first period. So how can you model that?
Put like 3 boxes, maybe.
Or 3/4.
So 4 boxes, maybe.
Yeah, that's right. That's what the quarters means. Yeah. Good. So 3/4. Can you find?
That's 3/4.
Yeah. Okay.
So
So let's find out this bit first. How many leads?
so we have to divide it by 4.
Yeah.
That would be 600. Yeah.
Okay. That's pretty good. Just did it in his head.
Guys are in your teeth.
Okay.
And then, so that would be 600. So then a third of them leave.
Yeah.
So,
So maybe draw a new bar. Okay.
so like another one of these?
Yeah. That's a good strategy to share. It's almost like your next line of working out. Draw a new bar. So it's not too crowded. Now watch this bit.
So it would be 150 each.
A third of them.
Oh, but wouldn't it be 150 for each?
Well, is that a third? Have you got thirds there?
No, 4.
Just 4. Okay. Good.
So let's try. So 200. So that was the one. No.
Now this bit I'm hanging back because I know he's going to solve a problem. Even though I want to say, do this.
400 left on the stadium? Yes. Yes. There are 400 fans left in.
He writes a statement to conclude it. What do you think of that bar model?
It helps.
It helps? Yeah, it makes it clear, doesn't it?
Yeah.
So for the first time, that's pretty good. When I started teaching, you'd have only heard my voice. I'd have been doing all the thinking for him. I said one or two things there, but as much as possible, I've learned how to hold back because now he's making sense of it. Bar models are absolutely fantastic. This is taken in the classroom. What grade classroom do you think this is? Let me show you.
3.
Grade 3. Grade 9 applied.
Okay.
Because even in grade 9, kids might not be too clear about proportional reasoning. And I went to a class at Father Austin about a month ago, and the teacher said, they're struggling with proportional reasoning. I said, let's start with concrete. Okay, so we had these rods to help them see that, if this was 20, 4 5s are 20, 5 4s are 20, so 20 is 4 times bigger than 5, and so on, just to get them up to speed with it. And then we gave them this puzzle here. So this is a proportional reasoning one. Okay, and in the past I've done this completely symbolically. But I'm going to show you. Should we show or should we get them to do it?
I get to make more money, right?
You get to make more money. So how might we solve this? Well, let's use a bar model. Christine, it's 3 times as much money as mine. Using bars, what would you do? Go on. Keep going.
Divide that by 4 into 4 sections.
And you're saying Christine has these?
Yeah.
And poor old Mike just has that one.
Yeah.
Do you agree that Christine has 3 times as much as me? That makes sense from that visual there? Okay. So I guess now, what is each one of these parts? What would you do to find out each part?
So what operation?
Because you said this was 330, and then you said split into 4 parts. It's got to be divided by 4, isn't it? So that's 165, 8250. 8250. Yeah. So each one of these is 8250. So Christine gets. What are you going to do to work out what Christine gets? Add them all up. What does Mike get? Not much. Not enough. Okay. But what does the question say?
How much more money does Mike?
So how are we going to find out how much more money?
So take away 8250 from
Christine.
8250 times.
There's different ways of doing this. You could do this. You could do 3 times 8250. 240, 246. That might be right. It might not be. I just did it in my head. Okay.
Two blocks.
Yeah, you see the comparative, right? Like you're like, okay, well, I can take away the 250 or the 8250 and the 8250.
Yeah, you could say that cancels with that, and this is how much extra she gets, which is just $165. Okay, and so what we're finding with bar models, you can sometimes see quite neat ways of coming up with the problem there. So there's this way of doing it. Some kids do it this way. They do Christine's one separately. They do mine. And what I like about this is that often with this sort of thing, kids get tricked into, they think it's a 3-ness question. It's got 330, it's 3 times as much. It's ratios, and they sometimes get tricked into do 330 divided by 310. So that's what Mike gets, Christine gets 3 times that much, and they don't check their work. But it's not a 3-ness question. It's a 4-ness question. Do you see? 3 parts for her, 1 part for me. Okay? And now we can see what we're going to do. We're going to divide 330 divided by 4. A bit like what we've done up here. And you could say in this case, well, this is the extra bit which he gets. The 100, was it 165? I can't remember. Yeah? So you see, bar models can be used even in high schools to help make sense of proportional reasoning questions there. So it's something which I've been using with my own kids when we're doing any work on operations. Is I'll illustrate it like that. And then there will come a point when they've seen the bar models in their head, and then they're just writing this down. And that's when they've gone from diagrammatic to symbolic. Okay? My problem in the past when I started teaching, I just jumped straight to the symbolic. Some kids may have understood it, most of them didn't. Okay? And I realized now that I was the cause of those misconceptions. And that's why I had to leave England. So we
I wondered.
Yeah. And the more we work in our schools, the more we're seeing bar models being used in primary and junior. We're beginning now to see them being used in high schools as well. And we're seeing more comfort with the kids actually solving certain problems. I understand as parents, if you've never seen this before, you might see some back and think, what are you teaching if all you've seen is the end product? But I'm hoping that you can see now the power of bar models and number lines and things like that. And so that I'm hoping that you can go and, yeah, I can actually do this with my sons and daughters, and I know what to help. The other thing is, this is not classified information. Okay? There are 100 people signed up for this tonight. Okay? Share it with those other people. Go back to your schools. Share this with the people you work with. Share this with people you have coffee with. And so it's a really neat way of showing kids how to learn how to solve a number of problems. Show them a bar model, or show them share something else that you learned tonight with them. Because the more people learn about this, the better it is for everyone, I think. And I think we really could talk to 10 o'clock, but we know we've all got homes to go to. Other ways to help at home, always see our Twitter feed at DCDSB Math for our problems of the week. They're kind of aimed at upper primary, junior, but they're fun questions to do at home with your sons or daughters. Okay? The University of Waterloo has an excellent set of questions for math contests from grade 7 upwards, but also they do a problem of the week from grade 3 upwards. And I know a lot of teachers share these. I get them sent home from my son, and we will sometimes do them together before dinner time. And there's also another one which I've come across recently. It's from the UK, and it's by a guy called Simon Singh, who's an absolutely fantastic author and scientist. And these are like enrichment activities, and they're aimed at grade 7, grade 8, grade 9.
and he's got like a little video which shows a really neat math concept, and it might be to do with cryptography or something like that. And then there'll be some questions, some puzzles to try after that. And it's something you can sit down with your son or daughter and say, let's just geek out and do some like really cool math together. And it's something they can submit their answers to, and they might get them right, they might get them wrong. But what I like about Simon Singh goes, it doesn't matter if you get it right or wrong, as long as you get involved. Okay, you will still learn something even if you get the wrong answer. Okay, so that's something else which you might want to try if you've got sons or daughters in grade 7. Great.
And I think we've used all our jokes up. Okay. So they're all over. Thank you so much for coming. Thank you for support, for all the help, all the work you do at home with your sons and daughters. Thank you.
Thank you.
Feel free to take some cookies home with you. You deserve it.